Demorgans law. Let's start with the first law, that is the first law. A union B, a complement is the same as A complement intersection B complement. Now, then let U just be our universal set, having a members that we say the members are 11 up to 20, the set of numbers. Then let's have A, which has 12, 13, 14, 15. Then we have B, which has 11, 14, 16, 17. Let's now prove. Now you see that when we say now, let's start with finding the A complement. These are the members that are not in A but they are in the set, in our universal set. And we don't have the elements that are in universal set that are not in A. The first one is 11, then 12, 13, 14, 15 are there. Then you can find there is 16, because it's 11 up to 20, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's why I put a dotted line. So you'll find that there is 16, 17, 18, 19, 20. So these are elements that are in A complement. These are elements that are in A complement. Again, let's check the B complement. In B complement, we are seeing 11 is here. So it means that we are 12, 13, 14 is here. Then we get 15, 16 is here, 17 is here. Then we with 18, then 19, then 20. These are elements that are not, they do not belong to B. We have our universal set ranges from 11 to 20. And that's now in B, we have 11 in B, 14, 16, 17. So the remaining elements, that is 12, 13, 15, 18, 19, 20, that are a universal set and they are not appearing in B. Those are the elements we say those are now B complement. The elements that belong to B complement. Yeah, and in simpler term, to make it easier, is that for you to get the complement of let's start with A or B, you just say that you take and the A complement is equals to all elements universal set minus elements in A. The same way we say that B complement is all elements universal set minus elements in B. Simple as that. Now, then let's check at now. Let's start with A union B. A union B, meaning that all elements in A and all elements in B. All elements in A and all elements in B. So you see all elements in A, we have 12, 13, 14, 15. In B we have 11, 14, 16, 17. So these are all elements. So but now we are getting the 14 is repeating itself. So just pick one of the 14. Let's arrange from ascending order. That is 11, 12, 13, 14, 15, 16, 17. This is an A union B. Now when you talk of A union B complement, which elements are this means that now you take the universal set minus A union B. The elements A union B. In universal set we have 11 to 20. So, and then we have 11, 12, 13, 14, 15, 16, 17, meaning that the remaining are 18, 19, 20. This is now our left hand side of the law. and now we get that now A union B complement is equal to 18, 19, 20. These are the elements that belong to that complement of A union B. That was the left hand side. Let's now tackle the right hand side. We had tackled the left hand side. This one was the left hand side here. That is the left hand side. So let's now tackle the right hand side. And in our right hand side, you'll find that now it is A intersection A complement intersection B complement. This is the right hand side, because the equation is that A union B, this is the law, is equivalent to A complement intersection B complement. So you have done with this part, so you're remaining with this part. So we are proving this part now, which is here. Then for that A complement, in our first equation we find that A complement, in A complement we found that these are elements that are not in A, and what we found was that the elements are 11, 16, 17, 18, 19, 20. These are elements in A complement. Then when we talk of B complement, the elements we found, it was that that is 12. We get 12, 13, 15, 18, 19, 20. Those are the elements we got from the first calculation, whereby we found that they are here, and then you can confirm that this is what we got, and this is what we got as well. Now what we are only doing, we are doing what we call that intersection between the two. Then the intersection between the two. That's what we are doing. Now the intersection between the A complement and B complement. So we'll find that which elements are common between the two. Then we'll find that 11 is not common, 16 is not common, 17 is not common, 18 is common because there is another 18 here. Then 19 is common, we have another 19 here. Then 20 is common, we have another 20 here. This shows that now the element that intersection is 18, 19, 20. These are the elements of intersection between A complement intersection B complement. And this proves that now the first one we got that A union B complement. We find that it was 18, 19, 20. Then the same, now we're getting A complement intersection B complement. Again we are getting, which is 18, 19, 20. This now are proof that now A union B complement is the same as A intersection A complement intersection B complement, and that is now 18, 19, 20 is the same as 18, 19, 20. These are the elements that are present in those two. And this is the left hand side, this is the right hand side, and we have Demorgans theory of sets. When I find that this A union B equals to A in complement intersection B, this shows now that they are equal, and this now is the final proof of the first law of Demorgans in the matter of sets, that now the elements are common. These are the same elements in A union B complement and A complement intersection B complement. Thank you.